Hello, my name is Muhammad Mirza Gama. My matrix number is 01 DKM21F1042. Now, I want to share you about what is trigonometry. As per its definition, trigonometry is a branch of mathematics that studies relationship between angle and length of triangles. The field of trigonometry emerged in the 3rd century BC when astronomers used geometry to study astronomy. These 3rd century astronomers were the first people who studied in this relationship between the length and the angles of a triangle. After studying in the depth research, they found that if the length of one angle is known, other angle of the triangle can be found with the help of simple manual algorithm. All their findings later on become known as a trigonometry function. In general, all trigonometry functions are associated with planar right angle triangle. Now, I want to share to you how about calculating sin, cos and tangent. First, sin equal to opposite divided by hypotenuse. Second is cos equal to adjacent divided by hypotenuse, and tangent equal to opposite divided by adjacent. Besides that, we also learn about cosecant, secant and cosecant. First, we are gonna look about cosecant. Cosecant is equal to hypotenuse divided by opposite. For the next one is secant. Cos equal to adjacent divided by hypotenuse. We got the secant, and the last one is the cotangent. Cotangent is equal to adjacent divided by opposite. Okay, thank you.
Hi, my name is Naresh son of Virasami. I am from DKM1B. My matrix number is 01 DKM21F1071. I am here today to talk about Group H prototype, and before that, I would like to greet good morning to my lecturer, to my engineering maths lecturer, Madam Intan, and also to my fellow classmates. Let's go to our slides. What is trigonometry in architecture? Trigonometric functions are used to calculate heights of structures like angles, exact intersection angles. Whether you are building an arc, dome, roller coaster or suspension bridge, trigonometry will help to produce a scale module using mathematical representation for a constructor. For example, we have used trigonometry to build this prototype. So trigonometry has helped us a lot in this prototype. For example, to calculate the angle in between these two bodies, and also to position these bulbs in this prototype. Trigonometry not only helps with calculation of heights, roof slopes, ground surface and light angle, but it also compute precision, loads and force. Recall that architects are not only responsible for redesigning mathematical representation of a designer plan, but they also have to ensure that a building is safe and functional. Further, sine, cosine and tangent functions in trigonometry help architects understand and calculate the force and loads. So trigonometry have helped us to produce a good and a very beautiful prototype in this project. For example, without trigonometry calculation, we can't produce a straight diagram or straight prototype like this. So we use trigonometry calculation also to calculate the angles for the bulbs to locate the lights inside, and the angles between these three triangles. and also to attach the 3 buildings. Next, let's see Hotel Rungyong prototype plan. This is the prototype plan. We have used hand-based draft plan and also AutoCAD. So before producing this prototype, we did some hand draft measurement and also plan, and then we did in AutoCAD 2D. After that, we produced a prototype so that this building produced in a very precise measurement and to ensure the building is beautiful. So as we see in the slides, you can see these are the samples measurement which we use, and exact measurement we use to produce this prototype. And this is Project Rungyong with some plants, with some lights. It's so beautiful. Let's see the equipment we used in this project. The equipment which we used: cardboards, hot glue gun, hot glue, trees or plants. It is real trees, it's real plant, not a plastic, wire, battery, LED bulbs. So we can tell about 95% things which we used is recycled things. So I would like to give some reasons why we choose Hotel Rungyong as our prototype project. We are choosing Hotel Rungyong for this project because this building is using trigonometry concept, and this building has a unique shape such as triangle. As you can see, we can't find the architecture like this in the world. So this is the one of the wonderful and beautiful architecture which we found in, which is located in North Korea. So we used the Hotel Rungyong as our prototype. If we want to find any angles, we can use trigonometry to solve it. For example, if we want to find the distance between two objects, we just need to connect the triangles and use trigonometry to estimate the distance in between of the object. So as example, if we want to know, for example, if we don't know the distance or the length of any of these diagram, we can use trigonometry to calculate it. So as example, I've used about 95% measurement we used trigonometry, tangent, cosine, sine. That's all for today. Thank you.
Hello and Assalamualaikum. My name is Muhammad Shazwan bin Safar, numerimetry 01 DKM F1080. Today we are going to make some exercise with using the trigonometry. Okay, we go to example question 1. The diagram shows Ahmad standing X meter from a hotel with a height of 100 meter above the horizontal ground. The elevation angle of the top of the hotel from Ahmad is 45 degrees. Calculate the distance of Ahmad in meters to the hotel. Okay, and the solution is we use formula tangent equal opposite per adjacent. Tangent 45 equal 100 per x. X equal 100 per tangent 45, and the answer is x equal 100 meter. So the distance between Ahmad and the hotel is 100 meter.
Guys and lecturer as well, my name is Sanjeev Raj Anaki Sarunan and my student ID is 01DKM21F1046. I hope that you can understand how trigonometry is related to architecture or to our prototype. Now let's look at the question. The height of the building from the tip to base, which has been marked as B and D respectively, is 330 meters approximately, which is the real height of the Ruyang Hotel, and the length from A to D is 89 meters. We also have to note that AB equals to BC and AD equals to DC. Find answers for the following question. Now the first question is to find the angle of A. In order to find the angle of A, we are going to use tangent. Why we are going to use tangent is because the formula of tangent is opposite over adjacent. We already have the value of opposite, which is BD, and adjacent, which is AD. So if we substitute the value into the formula, we can get an answer. For example, tangent theta or tangent A equals to 330 opposite over 89 adjacent equals to shift tangent multiplied by the value equals to 74.9. If we round off, we can get the final answer, which is 75 degrees. Now the second question is to find the length of AB. In order to find the length of AB, we can either use sine or cos. Why we can use sine is because the formula of sine is opposite over hypotenuse. We already have the value of opposite, which is BD, and we can use the value of theta, which is 75 degrees. If we substitute the value, we can get the length of AB. Or we can use cos, where the formula is adjacent over hypotenuse. For example, cos 75 or cos A equals to adjacent, which is AD, 89 over AB. Now to find the length of AB, AB equals to 89 over cos 75, and the final answer is 343.87 meters. Finally, the last question, which is to find the value of tangent to C. What is the formula of tangent to C? Well, the formula of tangent to C is 2 tangent C over 1 minus tangent square C. Now, as an extra tip, tangent C equals to tangent A. Why? Because in the statement, we have noted that AB equals to BC and AD equals to DC, which means the length on both sides are the same. Which brings us to, if the length and heights on both sides are the same, the value of theta also the same. So what is the formula of tangent? The formula of tangent is opposite over adjacent. If we substitute the values into the formula of tangent to C, which is equals to 2 open bracket 330 opposite over 89 adjacent close bracket, divide by 1 minus open bracket 330 over 89 close bracket power by 2, and the final answer is negative 880 over 1513. So I hope that you can understand the relationship between the trigonometry and the architecture or the prototype that you have made. The sub questions that I've explained to you are some values that you can find from the architecture by using trigonometry functions. Thank you.
Okay, and the last part is conclusion. First, we realized that trigonometry can be used in many areas such as architecture. They can aid in calculating many things. They can also be used in tower, tall building, and house. Second, without really climbing a tower, you can find the height easily with trigonometry. They can be so widely used in real-life applications and is very useful for most architects. Thank you.